Assalamu alaikum, students. The 2025 physics book introduces constructed response questions, or CRQs, which often look more complex than they are. If we approach them with a clear method, they become the most reliable way to secure full marks on your board exam. Take CRQ 1. It asks if the speed of light is affected by the relative motion between an observer and a source, just like the speed of sound. On the top half of the screen, you can see sound waves require a physical medium to travel. On the bottom, light waves propagate through a pure vacuum. Because light does not depend on a physical medium, its behavior follows a specific set of rules defined by Einstein's second postulate of special relativity. This postulate states that the speed of light in a vacuum, represented by the constant c, is 3 × 10⁸ meters per second. Notice that the equation remains static. Whether an observer is standing still, moving towards the source, or moving away from it, they will always measure the exact same value for c. Since c is the only value in these problems that remains the same regardless of motion, we will use it as our starting point for evaluating every other scenario on the exam. CRQ 2 asks a theoretical question. Can a massive object, like a star, move away from us at the uniform speed of light? To find the answer, we look to the 3 core formulas pinned on the right. A common mistake here is providing only a descriptive answer. To receive full marks, you must use the math. Specifically, you must write down the mass variation equation highlighted here. When we substitute the star's velocity, v, with the speed of light, c, the fraction c² becomes 1. 1 minus 1 leaves us with 0 in the denominator. Dividing the rest mass by 0 yields an infinite mass. Since accelerating an infinite mass would require infinite energy, the star can never reach the speed of light. Now consider CRQ 3. What if the speed of light were only 50 meters per second? 50 meters per second is a typical highway driving speed. If light moved this slowly, a car on the road would approach the speed of light relative to you. You would see the car physically compress in length, and the driver's clock would tick much slower than yours. The math shows that relativity is a physical reality at every speed. We simply don't perceive these changes because our daily movements are so much slower than the true value of c. CRQ 4 asks what would happen to the equations of relativity if the speed of light were infinite. Once again, we look at the Lorentz factor at the center of the board. Try this in your notebook. Place the infinity symbol into the denominator where c is, and see how it alters the equation. Let's solve it. Any finite velocity divided by infinity is 0. This leaves us with the square root of 1 minus 0, meaning the entire denominator resolves to 1. If the denominator is 1, proper and relativistic values become identical. All relativistic effects vanish, and the universe returns to the classical Newtonian physics we use for slow-moving objects. Our final question is CRQ 5. Can we use Einstein's E = mc² to create a single isolated electron from pure energy? As this diagram shows, the answer is no. Creating one electron would introduce a negative charge where none existed before, violating the law of conservation of charge. To keep the net charge at 0, the energy must simultaneously create a positron, which has the same mass but a positive charge. Examiners will also look for a second point. To obey the conservation of momentum, these two particles must travel in exact opposite directions, so their momentum vectors cancel out. The universe doesn't balance equations in isolation. Every time energy is converted into mass, the system must simultaneously satisfy the conservation of both charge and momentum. You now have the mathematical proofs required to handle these Chapter 11 questions. I've summarized the core points for all 5 CRQs here on the board. Take a screenshot of this summary to use for your final revision. If you use these specific mathematical steps, you will be well prepared for the exam. Take care of yourselves, and Allah Hafiz.